Let's learn to multiply. We will multiply an 8-bit number by another 8-bit number, yielding a 16-bit result. All these numbers will be unsigned. We know we need 16 bits because the maximum 8-bit number is 255, and if we multiply 255 by 255 in decimal, we get 65,025, which does not fit into 8 bits, but does fit into 16 bits. We'll multiply 9 times 11, or in hex, 09 times 0b. Now 11 is represented in binary as 4 zeros and 1011. Notice the ones are in the 1, 2, and 8 positions. That's 2 to the first power, 2 squared, and 2 to the 8th. Because 1 plus 2 plus 8 is equal to 11. We will call 9 x and we will call 11 y. Because there are 3 ones in the number b, there will be 3 additions. And there will always be 8 shifts because we're multiplying 8-bit numbers. The number 9 will be shifted as a 16-bit number and added to an accumulator that starts out as 0. This will take place in 8 steps as we work through the bits in the 0b byte. So the steps are A, B, C, D, E, F, G, H as we work from the least significant bit to the most significant bit of Y. Step 1, we take our number 9 and we see, is there a bit in the A position? And there is. So we add 9 to the accumulator, we double the 9, we shift it to the left, and it becomes 12 hex. 12 hex, remember, is 16 plus 2, or 18. And there's also a 1 in that B position, so we add 12 to the accumulator. And now the accumulator has the sum of 9 plus 12. We double our 12, shift it to the left to 24. There is no bit set in the C position, so we do not add to the accumulator. We go to the D position and double our bit, and we get 48 hex, and we add that to the accumulator because D has a 1. So we have 9 plus 12 plus 48. E, F, G, and H do not have any bits set, so we don't have to do anything. We would just go through the shifting and checking the bits. And when we add 9 plus 12 plus 48 hex, we get 63 hex, which just happens to be 99 decimal, which is the product of 9 times 11. Now notice, instead of multiplying 9 times 11, we could have multiplied 11 times 9 and got the same result, and it would have been a little bit faster because there's only 2 bits set in the 9, so there would only be 2 additions to the accumulator. In that case, we would have B and B plus 58, and when we get to the end, B plus 58 is equal to 63 hex, or 99 decimal. It comes out the same either way, but it's quicker to scan through the byte that has the least number of ones set. There's 2 other ways you could optimize this multiplication routine. You could be shifting Y to the right and then stop early when Y is equal to 0 and there's no more bit set. You don't have to be doubling X and not adding it each time because you know you're done. And you could also test at the beginning to see if X and Y are equal to 0 and just return 0, because any number multiplied by 0 will return 0. So that there is your 8 by 8 bit multiplication. Not as scary as most people think.